Good morning. This is your stats sensei, Mr. Spensey, and this is classwork for chi-square test of independence, lost cause. The Colorado Rocky Mountain Rescue wishes to study the behavior of lost hikers. If more were known about the direction in which lost hikers tend to walk, the better the search strategies could be devised. 200 hikers, so this looks like a sample size, are selected at random from the more than 200,000 applying for hiking permits. So this sounds like this right here is our population. This is our sample size. And and they're asked whether they would head uphill, downhill, or remain in the same place if they became lost while hiking. Each hiker in the sample was also classified according to whether he or she was experienced or novice hiker. The results and data are summarized in the table below. All right. Do the data provide convincing evidence of an association? Keywords: association, relation, dependence, independence. Lets us know it's a test of independence. Also, in this case, we happen to have one sample. All right. It says a random they took one random sample of 200. Single sample, more than one variable, and then it's a chi-squared test of independence. All right. So let's take a look at this thing. Do provide convincing evidence between the level of hiking experience and the direction the hiker would head if lost. All right, so we need to start off by writing our hypothesis. Well, I've kind of got a little bit of a jump on that. Hiking experience and direction are independent. And remember, if they're independent, that means they're not associated. Make sure, and also always remember the ho will always be positive. So this is a positive statement. They are independent. That's the claim. The ha will always be a negative statement, which is they are not independent. So, but please remember, independent means not associated. Not independent means they are associated. And I do want you to make sure you include that little part in parentheses. Random sample, should have said random sample of 200, but that was given. So we're good to go there. Checking the N is less than 10% of the population. 200 times 10 is 2,000. But they said that they were population size of 200,000. So we're good to go there. The expected values we'll come back to. We'll need to run those. We'll need to check those out. So we need to make sure that they're actually greater than 5, but we'll take care of that in a moment. Our formula for the chi-squared is observed minus expected squared over the expected. But I need to look at the degrees of freedom. So I need to go back and look at that table. Well, that table, we have 1, 2 rows and 1, 2, 3 columns. So we have a 2 by 3. And degrees of freedom equals row minus 1 times column minus 1. So in this case, 2 minus 1 times 3 minus 1. So this is 1 and this is 2. All right, so our degrees of freedom equals 2, because 1 times 2 is 2. All right. So expected values. Well, to find the expected values, we're going to need to go enter the matrix. And I haven't done it on this one yet, so it's going to take us a little bit of time. So we're going to go press the blue button for second. Then we're going to go to matrix where it says x to the negative 1. It doesn't show up very well on, but it's x to the negative 1 button right below the math button. Then press enter. Oops. Do that again. Second matrix. Edit arrow over the word where it says edit first, then press enter. Now I need to look at this. We have 2 rows and 1, 2, 3 columns. So it's a 2 by 3. So I need to change the size and make it a 2, enter, 3, enter. and I need to enter that data. And I just can type right over what I already have in there. So 20, enter, 50, enter, 50, enter, 10, enter, 30, enter, and finally 40, enter. Let me make sure I have that right. 20, 50, 50, 10, 30, 40. That looks good. Once you have that, you're going to leave the matrix. So second, quit. All right, I know this seems odd, but we're going to go ahead and run the test as if we're already going to act like we have everything we need and we're going to run it. So stat test, go all the way over to chi-squared test, which is letter C. Remember, GOF is goodness of fit, but we're doing test of independence, so we need letter C, not letter D. We're going to press enter. Observed, we're going to ignore that because everything is going to work out good. Calculator is smart. We get chi-squared to 1.5046, so we're going to go write that down. 1.5046. We have a p-value of 0.471. 0.4712, and an alpha. We didn't set the alpha, so we're going to make sure that we set it at 0.05, because if we don't have it. So this is greater than, so we're going to fail to reject. All right, so now we have all that information. Let's go back and we're going to get our expected values. So stat, second matrix again. We're going to re-enter the matrix. We're going to be cool like Neo. And we're going to go over to edit, and we're going to drop down to matrix B and press enter. So, all right, we have new numbers there. Those aren't the numbers we typed in. Why? These are my expected values. So my expected values are 18, 12, 48, 32, 54, and 36. So let's make sure we agree on that. 18, 48, 54, 12, 32, and 36. All right, so we have that. So let's go ahead and plug in. And remember, when we plug in, we always just want to worry about the first one and the last one. So our chi-squared is going to be 20 minus 18, our observed of 20 minus our 18 expected over our 18 of expected. We're going to skip some, and then we're going to drop down to our last one. Well, we observed 40, we expected 36 over 40. All right. So we've gotten everything done. We have our chi-squared value. We have a p-value, which is really big. So we failed to reject. The p-value is 0.4713. We failed to reject the null. There is not sufficient evidence at alpha equal 0.05 to suggest that a hiking experience and direction are not independent. That is technically correct. And remember, we're always restating our alternative. There it is. And that's what we said right there. We exactly copied our alternative. Now, that doesn't make as much sense from a grammatical standpoint. So if you prefer, the p-value is 0.4713. We failed to reject the null. There is not sufficient evidence at alpha equal 0.05 to suggest that hiking experience and direction are associated. Well, where did that come from? Hey, that's what we said. We said that they are associated. All right. So I hope that helps. I'll leave that up there for a moment and hope to see you on the next one. Thank you.